All right, so we're going to do a completing the square problem. Now, tell me, when I say square, what's that make you think of?
The the square thing you did, you made a
Like a
whole
picture?
square. Yeah.
Okay, let's make a picture. Let's put that in right here. Here we go. Here's our square. I am noticing there's a part of my square that's currently missing because obviously it's asking me to complete it. Would you agree?
Yeah.
Okay, but eventually when I complete it, we will have a complete square. True?
True.
All right, so here's what I'm going to try to do. How do I know that this shape is a square? Like it's a square because the it's symmetric. It's got the same side lengths. It's even everywhere, right?
Yeah.
Okay, so that's going to be the place where we start with. So let's start to organize this. I've got an x square. That's no problem. I can put an x square in a square. I'll put it right here. So far, so good?
Yeah.
All right. I need to organize this part so that it's even. Um, how can I split 1/6? I think the x would have been right here. How can we split 1/6 x up evenly? Does that feel a little weird?
Yeah.
All right, here's the next question. How would you split up 20 evenly?
Uh, added on. Subtracted on both sides.
No, I'm just asking. I give you 20 things. You and I are going to split it. How much do
Oh,
we each get?
10.
10 and 10,
10.
right? Okay, so what I'm saying is that you can take this thing and you can break it into 10 and 10. What if I started with 1/6 instead and we wanted to split it? What can we split it to? Sounds a little harder, right?
Yeah.
Okay, how did you go from 20 to 10? Let's go back to the process. How'd you go from 20 to 10?
Half. 10.
That's what we're talking about. So we're going to do the same thing here. I'm going to divide it by 2. Are you good with that?
Yeah.
Okay, now this is a little weird. Dividing fractions by 2, that's a little weird. What if I try to write that in a way that makes more sense to me? So I think of this as instead of dividing by 2, I'll just multiply by a half. Finding a half is the same thing as dividing it by 2. Do you agree?
Yeah.
Okay, what would that be?
1/12.
Okay, how'd you do that?
You multiply the 6 and 2.
Okay, and you multiply the 1 and the 1. And we can
Yeah.
check ourselves here because 1/12, if it was half, then that means if I put another half with it, I should get back to where I started, right?
Yeah.
And if I have one of something and I have another of something, that means I have two of those things, right? 2/12.
Yeah.
And you could simplify that to say I'm back at my 1/6. So there you go. Starting with one of these halves and then combining it with another half gets me back to the whole. So the whole divided by 2 must get me back to the half. Okay, we're good. So is it okay that I say that if I wanted to split this up in my square, I would need to put some of it down here, maybe like 1/12 of it here and 1/12 of it up here. That would keep it symmetric and pretty.
Yeah.
You see where I'm going? Let me know if I'm losing you anywhere.
Nah, I'm keeping up. I'm keeping up.
Okay, good. Now they're negative, so let's make sure that we split them up and keep the meaning. So that's going to be negative 1/12 and negative 1/12. So together they would get me negative 1/6, right?
Yeah.
Okay, good. Now that's all I have. This part is currently missing down here. This is the missing part of my square. I need to complete it. So you could think of this where I'm going to actually, oh, and I cleared it all. All right, we'll catch back up. X squared minus 1/6 x. I had put that into a shape that was an x square went here. I had negative 1/12 of an x that went here, and negative 1/12 of an x that went here, and I was trying to complete this shape with something that was missing to make it into a square, right?
Yeah.
So that I could eventually talk about it in terms of the square, where the sides are the same. How big are the sides? What times what gets me x squared?
X and X.
So is it okay to say that this square at the top left is an x by x square?
Yes.
Is it okay to say that this rectangle was made up by x times something?
Yeah.
What's it multiplied by?
Negative 1/12.
Fantastic. So I've got negative 1/12 here, and that's a negative 1/12 by x rectangle. In fact, this one down here is as well, isn't it?
Yeah.
So how big is this missing square right here?
Negative 112 times negative 112.
All right, let's do that. Negative 112 times negative 112 gets me what?
Is it 1 over 44?
1 over, try again.
1 over 40, 144, 144.
144, very nice. So that says if I put 144 things in here, by Kyla, if I put 144 things in here, I will be able to have, or 144th in here, I will have enough stuff that I will be able to describe this all as a square, right?
Yeah.
So that's exactly what we say when we say completing the squares. It means I need to add a certain amount of stuff here to literally be able to complete my square. Now we agree that everything we did over here took quite a while, right?
Yeah.
So we want to do this faster. So now we're going to pull away from this exploration just the meanings that we need. And so what did we actually do in process? Do you remember? What's the first thing we did?
We split negative 1/6.
You did, and you split that into halves, right?
Yeah.
So you could have written all this without the pictures as just saying take all this and divide it by 2. Or better yet, we usually write this as multiply by 1/2, right?
Yeah.
Because it's a lot easier to think of multiplying by 1/2 with fractions than dividing by 2 with fractions, right?
Yeah.
So that gets you negative 1 over 12. And then what did you do with the negative 1 over 12?
Multiplied it by negative 1 over 12.
So you multiplied it by itself. I'm going to call that squaring it. Literally, you made a square out of it. Do you remember doing that? That was up here.
Yeah.
All right. So that's what it means to make a square out of it. That got you 1 over 144. It is a two-step problem. You do this first, you do this second. And the way you can think about it in the future is you could write yourself a recipe. You could write yourself an algorithm. That's what mathematicians call it. And so it means take the algorithm is take B, where B is the number that is your linear component, or the number that's just being multiplied by x here. Take B, divide by 2, and you can say or multiply by 1/2, and then 2 would be square the result. That's how you complete the square if you want to just look at it in terms of a recipe, but the meaning comes from literally completing a square. In fact, the square that you completed is a x minus 1/12 square, because it's got x minus 1/12 on each side, which means the square is made by multiplying it by itself. Kind of crazy, right?
Yeah.
Because then you could expand that out, you could FOIL it back out, you get back to the original thing. How are we feeling?
Bamboozled.
Well, yeah, why?
Because it kind of looked a little. At first, when I did it, I thought it was gonna be difficult, and then the way you just showed how to do it, it seems easier.
Good. I'm glad. That's how you know that you know something, not because you can do it, because you understand why it works. So moving forward, you and I are going to agree that that's what we're going to pursue with all of the other problems in the class and forever onwards. If you ever feel like you're just doing stuff because you have to do it, you and I are going to talk, and we're going to figure out why we have to do it. Fair?
Fair.
Cool. Awesome. This was fun.